Hello all and welcome back to my YouTube channel. I hope you guys are doing fine. Welcome to the AutoGen series where we are learning how we can build a agentic application with the help of AutoGen. This is the 8th video in this particular series, and if you have missed out previous 7 videos, then I would highly recommend go ahead and check out those videos. The link for this particular playlist is already available in the description below. So go ahead and check out those videos as well. So in the previous session, we have started with a two-way agent conversation, basically the two-agent chat conversation, and we have seen how we can pass a message from one agent to another agent and how exactly the backend process works whenever the two agent converse in the AutoGen. In today's video, we are going to understand how we can build a sequential agent conversation pattern and how we can build the sequential agent in order to solve a particular use case. So let's get started with it. So let's understand what exactly is the sequential chat. So the sequential chat pattern is nothing but the name is self-explanatory, where the two or more agents are chatting with each other in the sequence, and the chain between these agents is connected with the help of conveyor, and that conveyor is nothing but the output generated by one model. We feed it to the another model. Now, this pattern where the multiple AI agents communicate in a order, we call it as a sequential pattern. So it's very simple basically. Let's understand this with the help of a simple example. Let's assume that there are 4 agents: Agent A, Agent B, Agent C, and Agent D. Let's say these 4 agents has their unique defined task. Whenever Agent A performs that task and generates the response, it passes to the Agent B. Then Agent B collect the response generated by Agent A, work on it and process that response and send it to the further sequential Agent C. And similarly, Agent C will pass the response to the next agent, that is Agent D. And whatever response this we are passing, this is nothing but the carryover response, or we can call it as carryover summary. So what happens whenever Agent A generates the output, it generates the output in summarized way, and that's what we have seen in two-way agent communication. We have a summarizer in between which summarizes the chat conversation happened between the agents and then pass it to the next agent. That's where, or this we call carryover mechanism. And this helps us reduces the token. So this helps reduce the token because we are summarizing the output, and that's where we are not passing the whole conversation to the next agent, and that's why we are saving the cost. Now let's assume that these agents had several tasks. Let's say the Agent A is a research agent. Agent B is, let's say, a draft writer. And Agent C is, let's say, a improve draft. And task of Agent D is to identify and correct factual errors. So that's the task of these agents. So what happens is, now this research agent will do the research, it will collect the data and it will pass that data to the B. Now B is a draft writer which will write the draft based on the custom format that you want. So for this particular agent, you can feed a custom format, so that based on that custom format, it will write the draft for you. And then the output of B will be passed to the Agent C. Agent C will improve that draft, and it will improve the draft accordance with your improver prompt. So whatever prompt you are providing to the Agent C, let's say if you want to elaborate any particular topic, then it will elaborate that particular topic, and Agent D will identify and correct if there are any mistakes. So that's how your major task of doing the research and generating the final draft will be sliced into these 4 agents, and that's how each agent has more capable of doing its own task. That's how now in this particular sequence, what you have done is you have break down your large problem into a independent problem. And this individual problem is solved by individual agent, and that's where you can give more prompt to each agent. You can have more control over each agent, and these agents will help solve the task for you. So that's how you can increase the accuracy as well. So let's understand one more example, and that example we will be solving practically. So this example is with respect to the arithmetic operator agent. Now let's understand what exactly the arithmetic operator agent works. So let's assume we have 5 agent A, B, C, D and E, and each agent has its own task. So how we can build the sequential agent is, let's say here you can see we have a first agentic conversation where agent A talks to agent B and generates the carryover chant. So, and for this the input is the context. Now we have discussed the context in last session. The context is nothing but we are passing the summary to generate the summary, and this message is the actual user message. So based on this particular user message, the chat will go to these agent A and B will do the conversation. In this case, agent A is the receiver, agent B is the sender. So this will send message to A will collect that message, it will carry forward that particular response. Again, agent A will talk to agent C. Agent A is your common agent, so that the agent A is your receiver. It will receive the response from all the agents, all other agents. And then similarly, again for agent C, you will have a context and message, another context and another message. So this way you can define the uniqueness for each agent, and that's how the communication will go till agent E. And as you can see, we are passing the messages that is generated by agent A back to these agents. So for agent let's say T, we have the input from agent A as well as we have the input from agent C. So the output generated by agent, the message given to agent A, output generated by agent B, output generated by agent C, all that summary we are passing it to agent D, and similarly to the agent E. Now let's assume that as a arithmetic operator, first one is let's say the addition. So this one is let's say a addition agent. This one is let's say a multiplication agent. This one is let's say a subtractor agent, and this is the divider agent. Now let's assume that the task of this particular agent, whenever the number is given, so let's assume this is a number agent. Number agent will generate a number. It will pass that number to agent B. Agent B will add one value to this particular number, and then it will pass that particular response to the next one. Then multiplier task is, multiplier will multiply that number by 2. Subtractor will subtract the number by 1, and let's say divider will divide the number by 2. So this is how the complete arithmetic operator will work. Now let's say assume that the number agent is passing the number 10. Now this 10 number is passed by agent A to agent B. Now what agent B will do, agent B will add 1 to 10, so it will become 11. The output generated by the agent A and B conversation is 11. So that summary will be carried over to the agent conversation A to C. Here we are not passing any input from agent A. So here it will be only the output, that is 11. So this 11, it will multiply by 2 and it will generate the output, that is 22. Now this 22 will be fed to the agent conversation A to D. So here it will have one input 22. It will subtract 1 from that, so it will become 21. Plus you can see we are passing the input from agent A. So the input from agent A was 10. So this it will pass 10 number. So this 10 minus 1, it will become 9. So for this we have two output, 21 and 9. Now this output will be fed to agent E. And now agent E, it has 22 minus 1, that is 21. So it will do 21 by 2, that is 10.5. Then the 9, it will do 9 by 2, that is 4.5. Now also it is passing the output that is carry over from agent A to C conversation, plus the output that is carry forwarded from agent A. So from agent A, we are passing 10 as a number. So 10 by 2, it is 5. And from agent A to C conversation, we are passing 22. So that is 22 by 2, that is equal to 11. So that's how the sequential transformation will work. So you can see we started with one number 10 and we ended up getting these many outputs 11, 5, 10.5, 4.5, those 4 outputs. This is the exact example we are going to see into the practical implementation. So I hope this is clear to you how the sequential agent works, and we have picked a bit complex example because now we are going deep into the series, so the complexity has increased. But yeah, whenever we are seeing the code, the things will become very clear for you. And why there are different context and message that are given to each, because in real-time application we are giving different context for each agent and different input user message. This can be a system message that we will be giving now, and we can define these messages based on the task that we want to accomplish. Okay, so without wasting time, let's straight jump onto the coding part. Okay, so we have opened our project code. So last time we have built the new notebook in conversation pattern. So under that, let's add the another pattern, that is sequential. Sequential conversation.ipynb. Okay, the file is created. So the first step is we need to import the necessary dependencies, as well as we need to import the LLM configuration. So this is the LLM configuration where we are calling a Azure OpenAI GPT-4 deployed model. We have deployed this model in our first video. So if you have missed that, go ahead and watch how we can build this particular LLM configuration. So we are using GPT-4 model. So let's call that particular model and let's set the environment path. So okay, as you can see, we need, let me remove temp file, it's not required. So we need a conversable agent from AutoGen, as well as what we are doing is we are defining the directory. We are setting the directory 2 step back because LLM config is available at root folder, and the sequential chat or sequential conversation file is available under this particular folder. So we are going 2 step back, and that's from there we are importing the LLM configuration. So we need to select the kernel. This is our virtual environment. So let's select that. Okay, now what we can do is we can start building the agent, and as we mentioned, we need a 5 agent. First one is the number agent, and then adder, multiplier, subtractor, and last one is the divider. So let's build the first agent. Now the first agent is nothing but number agent, and for number agent what we can write is, again we can call a class conversable agent, and under that we can give name as number agent. Then we can provide a system message, and this system message we can write something like this: you return me the numbers, I give you one number each line. So whatever number we are providing, the task of this agent is to return that particular number, and it needs to return the number at each line. So first we are giving one number, and then the output conversation going from another agent to that agent, number agent, there might be 2 numbers. So it needs to write 2 numbers, one after another in each line. Then we can call LLM config. That is nothing but the LLM config. And then we can set human input mode as never. So this is our first agent ready. Let's see, execute. Yeah, it's ready. Similarly, let me add the code for adder agent, multiplier agent, and I will add the code and then I'll explain each of the agent. Okay, so you can see I have added the agents. So let's say first one is the adder agent. We are giving the name to the agent. System message, you add 1 to each number, I give you, and return me the new number, one number at each new line. So whatever number we are passing to this particular agent, so this number agent will pass the number to adder agent. Adder agent will add one value to each number and return those numbers. And here, let me show you. So you can see we are passing system message, For each we have passed the system message. Context will pass it at the initiate chat level, because context attribute we can pass only at initiate chat level. So let's pass that whenever we are building the chat, wherever we are starting the chat. Similarly, let's say multiplier agent, we are giving name, you multiply each number, I give you by 2 and return each number at new line. For subtractor, we are subtracting by 1 and returning at each new line. For divider, we are dividing it by 2 and returning at new line. So that's the all agent that we have defined, and we have set human input mode as never, and we have passed the LLM configuration. So let's execute that. Okay, some error. Okay, here I haven't closed the bracket. Okay, the agents are ready now. Now let's define the initiate chat. So for initiate chat, let's write down the code. So we'll be storing the results into chat results, and then we can call number agent dot initiate the chat. So from number agent, we are initiating the chat. Okay, so in the initiate chat, now we are starting the chat with number agent. So we need to define all the remaining agents. And so initiate chat can take a list of agents. So let's define the list of agents. And for each agent, we need to pass one dictionary. And in that dictionary, we need to pass that particular agent details. So first thing that we need to pass is the recipient. So recipient is nothing but the adder agent. Then next we can pass is the message. And sorry, it's not equal to, it's a dictionary. Then the message is nothing but, let's start with 14 as a number. Then max turn we need to define, so that between two agents, what is the number of conversations that are allowed. So we can set max turn as 1, only 1 we want to add the number. And then let's add the summary method as we discussed earlier. So summary method, we can set it as last message, meaning generate the summary based on the last message or based on the conversation, and then pass that summary to the next. Generate the summary based on last message and pass it to the next agent. So that's how we have defined the adder agent. Similarly, we need to define the remaining agents. So we can add another dictionary for next agent. Let me copy paste that now. Okay, so you can see now we have added multiplier agent. We are multiplying again max turn. Let me change it to 1. Subtractor agent and the divider agent. Okay, so our initiate chat is ready. Number agent is talking to adder agent, multiplier agent, subtractor agent, and divider agent, right? And that's what we have built. A number agent, that is agent A, talks to B, C, D, and E. Is different agents. So you can see it is common across all, and it's exactly similar way we have built the code. Now let's execute this particular code. Now the chat conversation will start. Okay, let's see what is the error. Okay, sorry, it is not chat, it's chats. So that was the mistake. Let's execute the code. And again, it is not last complete message, it's last message. So sorry, my bad. So let's execute now. Okay, one more mistake we have done is we need to pass this parameter in string, because that's the first number and we should pass it in the string. So it accepts in the form of string because it's a message, not integer. So let's execute now. The agent will convert that into integer. Okay, now you can see that. Okay, I understood the issue. We have given name as number agent and we have forgot to give the underscore. So it is not accepting a space in between. So we need to give the agent name with underscore. And now we can start the conversation. Okay, so you can see now the conversation has started. Number agent given adder agent number as 14. The adder agent has added 1 to it. It became 15. Now again, it has terminated the run because max turn we have set to 1. It has reached. So conversation between number agent to adder agent has finished. The output is 15. So here you can see the 11. So now this particular conversation has finished and it has generated output as 15. Now the next turn, It has started from number agent to multiplier agent. And then multiplier agent has the number agent has passed 15 to this particular agent and it has multiplied it by 2. So it became 30. So this particular part. This multiplier agent, it has multiplied by 2, it became 22. The next part, again it has terminated the chart. Then it has started from number agent to subtractor agent. And now there are two numbers, 15 and 30. Now this 15 is nothing but the number that is generated by the adder agent. So here you can see the number generated by this particular agent is 15. So that is passed. And along with that, the number that is 30, which is generated by the multiplier agent. So for both, it has multiplied, it has subtracted 1 from that. So it became 14 and 29. So here I think I made one mistake while explaining. So instead of 11, it will pass, instead of 10, it will pass 11. So here the accordingly, please go ahead and do the changes. So it will not pass 11, it will pass, it will not pass 10, it will pass 11 as a number. And then for divider, now you have 4 numbers, because for divider you can see these 2 numbers plus the output generated by multiplier plus the now for divider you have 4 number, the output generated by the subtractor as well as the output generated by multiplier as well as the output generated by adder. So you can see you have 15 that is from a response from adder, 30 response from a multiplier, and 14 and 29 response from the subtractor. So it will divide each by 2. So and that's the reason. So we got 4 different results, and that's what we have seen here, 4 final outputs. And then it has terminated the run. Now as I mentioned, I'm really sorry, I picked 11, I picked 10 as a number, but it should be 11, and that's how please go ahead and update the responses here. Now what we can do is we can add one more complexity here and see how exactly it works. We have given max turn as 1. So you can see the turn conversation is happening only once and then it is terminating the chat. What will happen if we give max turn as 2? So it will do each operation 2 times, meaning this addition it will do 2 times. So 14 will become 16 because it will add 15. In next turn it will add 1. It becomes 16. So let's understand that. So what I'm going is I'm copying this particular and let's execute in further cell, and I'm changing max turn to 2. Okay, so I updated all max turns to 2 and let's see how exactly it returns. Now you can see that it has started the conversation. The first number given is 14. It has added to 15. Again, as the max auto reply, it has not reached. So 15 again it has passed to the adder. Adder made it as 16, and then the first conversation ended because maximum turn 2 reached. Now we have number at 16. Now this 16 it is passing to the multiplier. It will become 32. And again for the next turn 32 will become 64. That's what had happened here. And then it has terminated multiplier agent. Then for subtractor, now we have 2 numbers. 16 that is the output generated by adder, 64 the output generated by multiplier. It will subtract one value from 16 from 64 2 times. So first it became 1563 and in second turn it became from 1563 it became 1462, and then the subtractor agent conversation terminated, and then it moved to the last agent, that is divider. And for divider now we have adder agent output, multiplier agent output, and the last output of subtractor agent. Because we have given last message, that's where it is passing last message into the summary, and it is not passing the intermediate conversation, this particular conversation where it is doing the first operation. It is passing the last operation that has done, and then it is dividing to each number 2 times. First for these numbers it has divided by 2, 16 become 8, and accordingly the remaining numbers in first turn, and again in second turn it has divided by 2, so it became 8 became 4, 32 became 16, and so on, and then it has terminated the conversation. So isn't it interesting? We have built a arithmetic operator agents and we have requested agents to perform a task. Now this was a novel task that we have performed, but you can write your own logic for each agent, just like the example we discussed in theory, where research agent is transferring the draft to the writer agent is writing the draft, improver agent is improving the draft, and then final agent is doing the validation checks. Similarly, this arithmetic operator, you can change the arithmetic operations. Here you can change the sequence. Let's say you can change the sequence of the agents. You can have divider agent after the adder agent. You can play with that. You can change the max turn. You can change the input message that you are passing. Plus also you can change this particular prompt that we are passing to the agent, where we are subtracting by 1. You can mention subtract by 10, something like that. Try what if the negative number is coming. You can try those possibilities, and you can add those restrictions. So, and also you can play with by passing human input mode, and also you can change the termination message to is termination flag is available. You can change to that. So you can play with that, and I would highly recommend, please clone the repo. The link is already available in the description. Go ahead, clone the repository, try it out, and let me know if you have any questions in the comment down, and I will definitely try to reply to those questions. So I hope you enjoy this particular lecture, and I'll see you soon in the next lecture with a very interesting topic. And till then, if you want to learn about the Azure OpenAI services, how we can build the generative AI application with the help of Azure OpenAI Foundry, then I have built a complete course on Udemy. The link is available in the below description. Please go ahead and check out that course. So till then, keep learning, and I'll see you soon in the next video. Thank you so much.